In the first video in this two-part series, we gave an introduction to percentiles. We introduced the notation used for ordered data sets of percentiles, and we also learned how to start with a value in the data set, or a value related to the data if not actually in the data set, and then figure out the percent associated with its percentile. As noted earlier, this type of question is not actually common when working with authentic data. So we pick up here with the problem going in the other direction. What is more common is to be asked what a percentile in the data set is given some desired percentage of the data. That is, it is more common to ask a question like, what is the 10th percentile of the data? Or what is the 95th percentile of the data? Here we are going in the other direction. We've been given the percent, and we are now looking for the data value in the data set. Again, to clarify the vocabulary and notation, the kth percentile is the symbol p sub k, and this is the number inside the data set. The percent of data at or below this value is k%. So the percentile is not the percent is the data value. To answer questions like this, I will introduce the L locator method. The general algorithm goes something like this. You are looking for a specific lower percentage of the data. You obtain a location along the ordered data set for that percent, and then you determine the value at that location, or values closest to it. This protocol has a decision branching option, and thus I will show two versions of the protocol. We will work through two concrete examples, continuing with our mice dataset, and then I will provide the general algorithm for the L locator method to find a percentile in a given dataset. So the way a question is asked about the data would go something like this. What is the kth percentile of the dataset? This would be the value for which at least k% of the data is at or below that value. Again, if we're looking for the kth percentile, we are actually looking for a specific value in the data set. In other words, some x of I. We need a protocol to help us find the index I that would work. So, to start, we have to know what the desired percent is. Let's say we have been asked to find the 45th percentile of our mice data set. The way we find the index for the 45th percentile is using the L locator method. Not surprisingly, the locator, the index I from above, is called L. We'll use the lowercase script L for our purposes here. To find L, we start by locating L star. The formula for L star is K, the desired percent from the percentile, divided by 100 times N, the sample size. Again, L star equals K divided by 100 times N. Most of the time, this value L star is not a whole number. In other words, it is a number with a fractional part. To find the actual locator L, we take L star, the prelocator, and round it up. That is, we always round the number up to the next nearest whole number. The notation for the roundup function is like a pair of square brackets, but there's no bottom tick on these square brackets. So let's use the values for our problem. We obtain the prelocator L star by plugging in K, 45, and N, 125. 45 divided by 100 times 125 is 56.25. To obtain the locator L, we round L star up to the nearest whole number. Naturally, we would want to round 56.25 down to 56, as 56 and a quarter is closer to 56 than it is to 57. But for this protocol, we always round up. So, in this case, we round up to 57. The locator is L equals 57. This means that the 45th percentile is the 57th value in our data set, specifically our ordered data set. Looking back at our data set, we see that this value is 11.9. Restating all of this, with the color coding scheme provided here, the 45th percentile is the 57th data value in the ordered data set, which in this case is 11.9 grams. Let's look at this process graphically. Here we have the data set for our mice weights in a histogram with class width of 1/3 of a gram. And here we have shaded the lower 45% of the area of the bars for this plot. The question we are trying to answer is this. What is the data value that is the boundary for this lower 45% of the data? Again, we were given the percent 45, and we were asked to locate a data value. Here we see that 11.9 which we located as the 57th data value in the ordered data set, does indeed appear to be the value which separates the lower 45% from the rest of the data. The line and the bars do not perfectly touch, but that is okay. Recall, the definition for the percentile is the value for which at least 45% of the data is at or below that value. In this case, it happens that more than 45% is at or below the value of 11.9, but this is the smallest value in our data set that has at least 45% of the data at or below it. The second part of this algorithm is where things get a little tricky. This is when L star, the prelocator, happens to be a whole number. This means when we round L star up, it doesn't actually change. Thus, if L star is a whole number, then L, the locator, and L star, the prelocator, are the same number. In this case, we need to do something special. Fortunately, what we will do is similar to something we've seen already. When we were calculating the median for a data set with an even number of data values, we didn't take the middle number, because there was no middle number. Instead, we took the average of the two middlemost numbers. We will do something essentially the same here. If L and L star are the same number, meaning L star has no fractional part, then we will use the values at position L and L plus 1 in the data set. We will take the average of these two values, and we will use this as our percentile. For our demonstration purposes, let's find the 80th percentile for our mice data set. We will start with a graphical examination. Again, here we have the data set for our mice weights in a histogram with class width of 1/3 grams. And here we have shaded the lower 80% of the area of the bars for this plot. Given the percent, we want to locate a value from the data that can serve as the appropriate boundary value separating the lower 80% from the rest of the data. The question we are trying to answer is this: what is the data value that is the boundary for this lower 80% of the data? We will start with the prelocator. We calculate L star. 80 divided by 100 times 125 is 0.8 times 125, which is exactly 100. If we round 100 up to the nearest whole number, we just get 100. Thus, L equals 100. So L and L star are the same number because L star was a whole number. It did not have a fractional part. Now, instead of using x sub 100 from the ordered data set, we will use the average of x sub 100 and x sub 101. Retrieving these values from the data set, we get the weights 12.6 and 12.7 grams, respectively. The average of these two weights is 12.65 grams. Summarizing, the 80th percentile for the mice data set is the average of the 100th and the 101st data values, which is 12.65 grams. And here we see that plotted graphically. Again, the 80th percentile is the data value, or a value related to the data set, for which at least 80% of the data is at that value or below. For our data set, 80% of the data is at or below 12.65 grams. Let's summarize the protocol to find the percentiles for a given data set. First, we calculate the prelocator, the value for L star using the formula k divided by 100 times n. We then round L star up to the nearest whole number. This is the locator L. Now, before we locate the values in the ordered data set, we examine the value of L star. If L star is not a whole number, then we locate the value at position L in the ordered data set. In fact, it may be good to reiterate that there is a step 0 in this process. The 0th step is to make sure the data set is ordered. Now with that ordered data set, we can locate the Lth value in the data set, and this would be the kth percentile, if L star is not a whole number. If L star is a whole number, then we locate two values from the ordered data set, the value at position L and the value at position L plus 1. The percentile is then defined as the average of these two values. Before proceeding, I will briefly mention that this by hand method is meant to be pragmatic and easily accessible. There are more complicated ways that the percentiles can be calculated. One additional level of precision that might be added to the protocol is to not take the average, but an extrapolated value somewhere between the two values. This is not necessary for our purposes here, and I only bring this to your attention because it is possible that if you request a particular percentile from a software program, the app may return a slightly different value from the one you might obtain using this by hand approach here. Again, Remember what we said earlier. There are 1,000 ways to do the same thing in statistics, and we see this with statistical software packages all the time. While the values may be off by a little bit, in general, they should be close, and the overall interpretation is safe to use for either the by hand value, as obtained here, or the value produced by the statistical software package. Now, to bring this full circle, let's revisit the median. Recall, we said the median, as the value in the middle of the data set, should essentially be the 50th percentile. If we use the protocol here with our data set already in order, we find L star, 50 divided by 100 times 125, which is 62.5. Now we round this up, as it is not a whole number, to get the locator L equals 63. The 63rd value in the ordered data set is 12.0 grams. Note, this is the same value we would obtain if we calculated the median by hand. Sort the data and locate the middlemost value. With 125 numbers, the 63rd number separates the lower 62 values from the upper 62 values. That is, we find n plus 1, all divided by 2, that number in the data set. 125 plus 1 is 126. 126 divided by 2 is 63, which is the same location we obtained using the L locator method. While not demonstrated here, if the dataset had an even number of data values, then the L star using the L locator method would indeed be a whole number, and we would have to use two numbers to find the median, just like we had to do when calculating the median by hand with an even-numbered dataset. Thus, the two approaches to calculate the median by hand and using the 50th percentile give the same value. I hope this introduction to percentiles has been useful. In the next video, we will explore the 5-number summary and box plots.